Good morning, Grade 7, and welcome to WorksheetCloud, Grade 7 Natural Sciences. If you have a question during the lesson, please feel free to send an email with your question to grade7@worksheetcloud.com. Good morning, I am Mrs. Hall, and I'm here to teach you about the physical properties of matter. The objectives for this lesson are as follows. We are going to leave this lesson understanding the following terms: compressive strength, tensile strength, flexibility, boiling and melting points, heat or thermal conductivity, as well as insulators. Let's start with what is a physical property. A physical property is a characteristic of a substance that does not involve a chemical change. Physical properties can be observed or measured. You can tell that an orange is an orange by looking at it without changing the orange's identity, such as burning it or melting it. There you have your orange. A magnet would have the physical properties of magnetism, strength, and the ability to conduct electricity. Those are all physical properties. Let's take a look at this metal car. I want you to look at it, give you a couple of seconds, and describe some physical properties of the image below. What do you observe with this car? Firstly, it's a metal, yes, and it has a shine to it, a luster to it, and it also looks very hard. Those are properties that you can easily observe, but there are other properties of metal that are not easy to observe, such as malleability. We do say that a metal is strong and durable, but it can also have malleability. If it has this property, it means that a metal can be formed into sheets which can be used for a variety of different purposes. You can press body panels for a car. Now, a good example is gold. It's a very malleable metal, and basically you hammer it into very thin sheets, so it's flat. A metal can also be ductile. This property, ductility, means that a metal is able to be drawn out into a thin wire. And a very good example here is copper. Copper is a very good conductor of electricity, so it is also very ductile and is used in copper wiring in our plugs at home. The physical properties we are going to look at today, Grade 7, are as follows. We are going to look at the strength of an object, the flexibility, the boiling and melting points, the electrical conductivity, the heat conductivity, as well as other factors to consider, such as cost, color, and texture. Let's take a look at the different kinds of strength. First of all, we get compressive strength. Now, compressive strength is the resistance of a material to breaking under compression. It cannot change shape when pushed or squeezed. And a very good example here is a concrete bridge. It cannot change shape when pushed or squeezed. It has compressive strength. Tensile strength is the strength of an object that stops it from breaking when pulled apart. And a very good example over here you can see is a steel bridge. It can withstand tension. Flexibility is another physical property we're going to look at today. This is a measure of how easy it is to bend a material. Flexible materials can bend without breaking. And a very good example here is the components of a 3D printer. They need to be flexible in order for the printer to print out the 3D object. Currently, we are very lucky in South Africa as we are using 3D printers in our homes to print out the masks for the doctors and the nurses that need these to protect them from the virus, COVID-19. So it's very important that flexibility is a physical property. Another object that we use in our everyday lives is a hose pipe. It's flexible. Imagine it was made out of metal. Would you be able to water the garden with a metal hose pipe? No, it has to be made out of rubber so that it is flexible, so you can move around and water all the different flower beds. Let's recap grade 6 knowledge, just to go back so that you understand where I'm coming from. When we talk about the state of matter, we talk about the physical form in which a substance exists, such as a solid, a liquid, or a gas. What would be a substance that can undergo all of the states of matter in a very short period of time? Quick recap, grade 7s. Solid, particles very tightly packed together. They vibrate. They do not move around freely. Liquid, particles are slightly more apart. They are able to flow and move around each other quite easily. A gas, particles are far apart. They are able to randomly move in all directions, and because there's so much space between them, they move quickly. Let's take a look at boiling and melting points. So boiling point is the temperature at which a liquid turns into a gas. I say at about 100 degrees Celsius. Here we have a boiling pot of water and it's starting to boil, probably at around 100 degrees Celsius. Melting point is the temperature at which a substance melts as it changes state from a solid to a liquid. And again, I say at about 0 degrees Celsius. Here we have a block of ice with the melting point of 0 degrees Celsius. Why do I say about 100 and about 0? Because the conditions are not identical, grade 7, at the same time. Pressure and impurities, such as chemicals in the water, make a big difference to boiling and melting points. Let's take a look at this slide. Describe how the H2O has undergone a physical change. Now, H2O is water. It contains 2 hydrogen molecules and 1 oxygen molecule. That is the chemical formula for water. How has this water undergone a physical change? How did it change from a solid to a liquid to a gas? Well, let's start off with its solid form. When we add heat, the ice will reach its melting point and become water. When it's in its liquid form and we add heat, water will reach its boiling point and become water vapor. The same happens with the reverse process. We remove the heat and the water vapor will become water through the process of condensation. The liquid water, if we remove the heat from water, the water will then reach its freezing point through the process of freezing and become a block of ice. Throughout this whole process, the chemical formula of water, H2O, did not change. It stayed the same, whether it was in its solid form, its liquid form, or its gas form. The physical change is a change of matter from one form to another without a change in the chemical property. Like I said in the previous slide, the H2O always remains H2O. If you hammer out a raw block of aluminium, due to aluminium being malleable, remember the term? We learned about it at the beginning of this lesson. You are causing a physical change. Balling up a piece of paper is not changing the chemical property of the paper. It's creating a physical change only. The paper still remains paper, exactly like the water, whether it was a block of ice, a bottle of water, or a gas, it was still always water. What if the paper were ripped? Would it be considered a physical change, grade 7? Absolutely, yes it would. It would still be paper. It would be a physical change. Is boiling water a physical change? Explain why or why not. Think about everything I've just told you and think for yourselves. I'm going to give you a second here, grade 7s. Yes, boiling water is a physical change. The water stays the same. I have an activity for you to do for homework. You can download this worksheet off WorksheetCloud after you finish watching this video. And I want you to do this investigation. And you can do it at home in your own kitchen. I want you to investigate what happens to water when it reaches its boiling point. Now, before you start this activity, please make sure that you have parental help or someone watching over you. We need to be very careful, grade 7. Safety comes first. Okay, please, I don't want anyone getting burnt. In a normal situation, we would be in a classroom, or the apparatus would be set up, and it would be a very controlled environment. So please, grade 7s, be careful. So instead of using the apparatus in a classroom, I changed the apparatus so that you could just boil water on the stove at home. You do need a thermometer for this, so I'm pretty sure you've all got thermometers at home. But with using a thermometer, I also want you to be very aware that a thermometer conducts heat. So when you're putting the thermometer into the boiling pot of water and taking it out, please make sure that you are using an insulator to remove it. And I'm going to explain all of that to you now as we go on to our next slides. So remember, a thermometer is a thermal conductor. It allows heat to travel through it. So be careful when picking it up. You can time the intervals between taking the thermometer out of the pot and putting it back in either 2 to 3 minute intervals, completely up to you. This worksheet set up at 2 minutes, but it can also be 3 minutes. The graph will not change. Read through the instructions carefully, and then I want you to come up with your conclusion from this investigation. Okay, good luck, enjoy, but again, I reiterate, stay safe. Let it be in a controlled environment. To determine if a physical change has taken place, answer the following questions. Can you reverse the process? So can you go backwards? Can you reverse the process that the substance has undergone? And do you still have the same substance, or is the original substance still present? That is how you determine if a physical change has taken place. Now, as I was saying earlier, I said we were going to mention electrical conductors and thermal conductors. So materials that allow electricity to move through them easily are called electrical conductors. Materials that do not allow electricity to move through them are called electrical insulators. So we are looking at electrical conductivity. Here we have an example of electrical conductivity with the copper wires here that have been rolled into thin wires for electricity to pass through. What is that process? Ductility. Do you remember from the beginning of the lesson? Right. This is an electrical conductor. It allows electricity to pass through it easily. However, surrounding the electrical wires, the copper wires, is plastic. That is an electrical insulator. It does not allow electricity to pass through it. So if there's any problem at home in any of your wiring of your plugs or anything like that, then obviously if there's a short circuit, a fire cannot be started in your home because the wires are well insulated, as well as the plug sockets. They're also made out of plastic, which is an insulator and does not allow electricity to flow through it. So if there is something wrong at home, generally this will just melt. It won't catch on fire. And it's also a pre-warning to a fire breaking out, which is good to have. A little mini project at home, another one for you. Quite nice to do some practical activities today, grade 7. I want you to ask your mom or your dad how to wire a 3-pin plug. I bet none of you actually know. So that's your research. You're going to open up a plug and you're going to wire the 3-point plug. You're going to learn what each different color over here is for. So you have your yellow or your green wire, your brown wire, and your blue wire. Go and do the research and learn. So the next time you have to set up your own TV or your own radio, plug it in, and the plug stops working, you can rewire it. That's a lovely project to do during lockdown. We're now going to look at heat or thermal conductivity, which I mentioned earlier. With the thermometer, if you have a glass thermometer, it is a good thermal conductor. So listen carefully to the definition and you will understand what I was telling you. Thermal conductivity is the rate at which a substance transfers or allows heat to travel through it. Okay, so it allows heat to travel through it, like the glass thermometer will allow heat to travel through it. So ask yourself, which heated pot would you have to use a pot holder for when grabbing the handle? So look at this pot here, it's a copper pot. And look at this pot over here, it's an aluminium pot, but it has a plastic handle. And over here, there's no covering, it's just a normal copper handle. Now, both of these materials are good conductors of heat. They both allow heat to travel through them, and that is why they're placed on the stove. Right, so while you're cooking, the heat is evenly spread throughout the food and your food is cooked. It transfers the heat from the hot plate to the metal pot, which transfers it to your food, which is then cooked. However, when you need to take the pot off the stove, when you finish cooking, is it a good idea to grab this pot by the handle or this pot by the handle? Obviously, you want to grab the one that has the insulator, the plastic handle, because it does not allow heat to travel through it. So, cool, easy to remove off the stove, not so cool, blister heaven. You need to take one of those plastic pot holders or a tea towel, wrap it around the pot handle, and then you will be able to remove the pot from the stove. Are you understanding, grade 7s? Maybe another home project is you could cook the dinner tonight. I bet you I've got some moms in the background. Yes, yes, please. Other factors to consider when selecting the right materials. So not only do we look at all the other physical properties that we discussed earlier, but we also need to look at appearance, style, texture, cost, and color. So just as an example, I have 2 chairs here. This is a lovely, comfy chair, and this is a hard chair, not as comfortable. Which of these 2 chairs would you choose to watch Netflix in? That's easy. Right, we're going to choose this beautiful one over here. Not only by its appearance, it's also got a lovely style, easy to relax in. Its texture as well, it's soft to the touch, it's comfortable. The cost for both would probably be in the same ballpark, and obviously even the color. So you want to choose this chair to watch Netflix in for those specific physical properties. It offers the best relaxation, the best way to get comfortable and enjoy that movie. Whereas this chair over here, you're not going to sit and watch Netflix in this one. You're going to do your homework in this chair. for its appearance. It's sturdy, it's strong, the right style, keeping you upright and focused. The texture is hard. You're not going to relax and just cuddle up in this chair, grade 7s. You're going to cuddle up in this one over here. So those are other factors to consider when selecting the right materials for whatever it is you might need it for. A little bit of extension for those of you that want to just go that little bit further. I've been speaking a lot about the physical properties of a material, and we didn't really even mention the chemical properties. So what is the difference between a physical and a chemical change? And you do go into this in a lot more detail further on in the curriculum. The difference is a chemical change is a change that occurs when a substance changes composition by forming one or more new substances. So the substance changes. The new substance or product that is formed have a different chemical formula, so it won't stay the same. So like water stayed the same, it's a physical change, H2O. A chemical change, the water would not stay the same. It no longer is the same. It has a different chemical formula from the original substance or reactants at the beginning. Take a look at this example. Is the log undergoing a physical change when it's burning? Explain why or why not. Remember the question you need to ask yourself, grade 7. Can you reverse the process? Will it go back to its original form? Think about it. Right. This log burning on this fireplace is undergoing a chemical change. The substance that is formed is no longer the same as the original substance. It is now ash. It is not wood. Do you understand? Are you getting it? I hope so. Thank you for watching, grade 7s. I really hope you learned something new. Again, download the worksheet, the activity that I set up for you. I wanted to try and give you something practical to do today. Not just sitting at your desk writing. Go and do the investigation. But again, please, grade 7, be careful. The memo will be there for you as well. I hope you enjoyed this lesson. Now, after sitting like this for 20-25 minutes, please, grade 7, jump up and down, do some star jumps, get active, get moving, healthy body, healthy mind. See you tomorrow.